with a brake, and you want this brake to have maximum pressure on a horizontal surface. You need to put this side, put it like this, right? In order to have highest pressure, because the area in this side is smaller. Do you understand?
Mm-hmm.
So because if you put like this side has a maximum area, so you will have less pressure. If you put like this, you will have higher pressure. Do you understand here, right? So we need to use this side. We need to put this side in order to have highest pressure, maximum pressure. And this side, the area is 0.1 times 4, which is 4 times 10 to the negative 3. And then we know it's 50 Newton. So the weight over the area, that is the pressure. It's 50 over 4, 10 to the negative 3. And you will get 12.5 K. Okay, so this one is fine. So these two. And then number 3. What is the gauge pressure if the absolute pressure is 300 kilo? So if the pressure is 300, that's absolute pressure. What that means? So, for example, if when we calculate the pressure here, it doesn't. That's the gauge pressure. It doesn't include the pressure from the atmosphere, right? When we include the atmosphere, the pressure should be 101 kilo, right? That's from the atmosphere. So if that the absolute, the gauge should be absolute minus the standard atmosphere pressure, which would be 299. Okay, so this one you understand? Number 3. And then number 4, what is absolute pressure at a location 15 meters below the surface of the sea? So 15 meters below the surface of the sea, we expect to have a pressure density, gravity, and the height, right? That's how you calculate the pressure. Plus, because you want to calculate the absolute pressure, you need to add the pressure of the atmosphere. So what you got is, because water we gave to you is 1030 kilogram per cubic meters times 9.8 times 15 meter plus 101 K. Okay, so if you calculate it, we got 252410. Okay, so the answer should be C, 2.52 times 10 to the 5th. So that's number 4. Okay. Number 5. piston. So a 500 Newton. The idea for this kind of question is the pressure for the small piston and the large piston should be the same. We know, so pressure on one side should be the same as the pressure on the other side. And the small side is, is 500 over 2. And the large side, we don't know the force. What we know here is 40. So if you calculate it, 500 times 20 is 10,000 Newton. Okay. And then number 6. Similar to the number 5, small piston also pressure from the small side should be equal to the pressure in the large side. And we know here the diameter is 8 centimeters, so the radius is 4 centimeters, which is 0.04 meter. And the large side is 20 centimeters, which is 0.2 meter. Okay. And this side you can lift with a load of 15,000 Newton. The question is, this side, what's the force you need to apply to small part? So it should be the force over the area, which is pi r squared, right? Should be the same as this force over this 0.2 squared. Right? As pressure is the same. And cancel pi. This r is this. And if you calculate, we can get 600 Newton. Okay, that's A. B is what's the pressure applied to the fluid in the lift. What's the pressure? So you can calculate this one or this one is the same. Should be equal to the force over the area, and you can got okay. So that's number 6. And then number 7, a block of metal weighs 40 Newton in air and 30 Newton in water. What is, how to pronounce this? Buoyant?
The buoyant force.
Buoyance.
Yeah.
Because it's from the water, right?
Mhm.